C. Application of linear programming. Have a look. What is linear programming? This one actually is a branch of mathematics that deals with maximizing or minimizing a linear function subject to a number of constraints, and it's called linear programming. Okay, give you an example, 8.3f. Now we want to maximize C. This one we call it as an objective function. C equals 2x plus y, objective function. We want to maximize this one under these constraints, subject to these three constraints. Okay, this is a typical example of linear programming. If we want to maximize or minimize a linear function under several constraints, we have two methods here. Method 1, draw a parallel lines of the objective function. That means now you have this objective function, then we need to draw parallel lines. Okay. Secondly, have a look. After you have a line, okay, maybe this one, we draw ax plus by equals 0 first, then we use this line and then draw some parallel lines about this. C may be different values. If we shift the parallel lines, the first point of the regions that the line passes through, this one in usual is a minimum value. Okay. The last point of the region that the line passes through will be the maximum value. Okay. Okay. Then have a look. Method 2. This method, most probably we use all the points, okay, all the vertices of the regions, okay, all of the vertices of the regions. Okay, put the pairs of x and y into objective function. Okay, put the pairs of x and y into objective functions and find out the maximum or minimum value of C. Okay, before we look at one example, teach you a useful technique for method 1. That means if we draw a line with a slope m passes through 0, 0, then how can we do it? Okay, here slope equals 3, right? You can think it as 3 over 1 or negative 3 over negative 1. So we have 2 points. Remember, slope equals y over x, right? So this one you can think it as 1, 3, and the other point negative 1, negative 3. Okay, this one is y and this one is x. So 1, 3 is one of the point. The other one, this one y, this one x. So negative 1, negative 3, right? Afterward, draw a straight line. Here, remember, draw straight line. X, y, 2 axes first. Okay, this point is 1, 3. This one is negative 1, negative 3. Okay, so here, this straight line slope equals 3. Okay, so have a look. The next one. Slope equals negative 1 over 2. You can think as negative 1 over 2 or 1 over negative 2. So which 2 points that will pass us through? Yeah, one is 2, negative 1. The other one, negative 2, 1. Right. So again, I draw 2 axes first, x and y. Here is 0. Okay. 2, negative 1. Negative 2, 1. Okay, so you found that this one are okay. As a straight line passes through, right? Yeah, so this one slope equals -1/2, right? So if we know about the slope of the straight line, that's easy for us to draw. Okay, we know the slope now, and what are 2 points? Can you tell me? Or can you tell yourself? Yeah, one is 4, 3, correct. Another one, -4, -3, correct. Okay, so this time I will shift a little bit for the axis. Here, x. And this one is y. So 4, 3, right? Okay, and this point must pass through 0, 0, so I draw it like this. So this one slope equals 3/4, right? One more examples, hope you understand. -2/3, right? Or 2/3. So which 2 points? Correct. One is 3, -2. The other one, -3, 2. Correct. So now again, draw straight line x. 2 axes first, 1 and 0. Here 0. Okay. 3, -2, -3, 2. So now passes through. Oh, yeah, very good. So this one slope with -2/3, right? This one can help you to draw the objective function. Okay, draw the parallel lines. Okay, after draw one lines, then you mark the parallel lines to find out which one is the first point, the region that the line passes through, and where is the last point of the region that the line passes through. Okay, so we need to take one examples. Okay, maybe next video have a look 8.3k and do it once again.